2022 External Additional Math, Paper 1. This must have been question 5, not read it 2. I think I just made a mistake there. So one of my students shared this, like many other problems in this paper. This one was challenging. So let's just try to prove it together. So you can either use this side or this side, but it's much easier to use this side because this is complicated. Your job is to simplify it to obtain this. So as you can see, we have a cosine and a cosine there. So what you want is something like this. So whatever you do here, aim for this. As you can see, we do not have any denominator, so let's start with the denominator first. So we can say sine theta minus cos squared theta minus 5, everything over. Tan is sine theta over cos theta, and then plus sec is 1 over cos theta, so you can write this as 3 over cos theta, like this. So now you can just put this in brackets so that you can divide it by that. But before we do that, let's just simplify this and see if we can get something interesting. So everything over, the denominator is common, so you can just say sine theta plus 3, like this. And then now we can divide these two because you don't want the denominator. So you have sine theta minus cos squared theta minus 5 divided by this, which is sine theta plus 3 over cos theta, like that. So now for division, we all know that you can always convert it to multiplication by reciprocating the other fraction. So this one will be reciprocated. The denominator becomes the numerator and the numerator becomes the denominator. So at this point, when you expand, you won't get anything interesting. So what you want to do is, as you can see from here, we have sine theta cos theta minus 2 cos theta. So cos is common, so you don't want to change this. If anything, you want to factorize this. You factor the cos out so that you have this. So whatever you do here, aim to obtain an expression like this here, and then another expression like this, which will cancel it out. So now how do I do that? I can't cancel these two out because we have a sine, we have a cosine, we have a constant, and we only have a sine and a 3 there. So you can just change this cosine to sine so that you have something which can factorize to this and that. So let's do that. We can say sine theta minus, from the first identity, this one here, I can make cosine the subject, cos squared, this would be 1 minus sine squared theta. And then I can use this where there is sine. So I'll replace this. Let me use square brackets so that I can accommodate this, minus sine squared theta. The brackets here are very important because of this minus. And then multiplied by cos theta over sine theta plus 3. And then now you can expand this, so you can say sine theta minus 1 plus sine squared theta minus 5 multiplied by cos theta sine theta plus 3. And then you can just rearrange these terms. As you can see, this is a quadratic expression in theta. So I can just start with theta, like this, followed by sine theta, followed by -1 and -5, which is basically just -6, multiplied by cos theta over sine theta plus 3. And then now I can factorize this so that I can get something which will cancel out with this, and then another thing which will give me something like this. Remember, this side, when you factor out the cosine, you should have this. So the only way you can do that is by factorizing this quadratic expression this side. So to factorize this, of course you can factorize it using sine as it is, but to avoid confusions, you can just let your sine, you can just say let's say x be sine theta, so that your quadratic expression is x squared plus x, so I'm replacing the sign with an x, and then -6. This is much easier to factorize than that. But if you can factorize it like this by saying the product is the coefficient of this and that, which is -6, and then the sum is a 1, then that's okay too. So the product is the coefficient of this times this, which is -6, and then the sum is a 1. So the factors here will be, this should be 3 and 2, and then because this is positive, I can negate this. So this one will be x squared minus 2x, and then plus 3x minus 6. Then you can factorize this. So this one will be an x, then an x minus 2 plus a 3 and x minus 2, and then these two are common, so you can factor them out so that you have this. But remember, this is sine theta and this is sine theta too, so you can just replace these things in there. So when you factorize this, you get x is sine, so this will be sine theta, and then -2, then you close, you have another sine theta plus 3, then multiplied by this part here, which is cos theta over sine theta plus 3. So now to prove your identity, as you can see, this is the same, this is the same as this, so these two will just divide. Remember, you don't want this, you don't want that, all you need is this and that. So once you have sine theta minus 2 being multiplied by cos theta, you would have proved the identity by just expanding these two. So this times this is sine theta cos theta, and then minus this times this, you have 2 cos theta, and you're done. So this is what we started with. We had sine theta cos theta minus that, and we have verified the identity. We have actually proved that the identity is true in general.